Okay, so this document is last updated on Monday, the 15th of April, 2024. And it's continually worked on, so the set's going to grow. But I'm going to go to the end of the document, which at this point is page 932, and then go backwards and explain to you how I do the document. I look for questions. This number question, it's not numbered yet, but it's footnote 167. And it comes from the Stanford Math Tournament. It's a high school exam. It's from the 2013 version. All right, so what I'll do is I'll go to the whiteboard and do it, but before I do that, I want to point out, it's suppose A and B are real numbers such that they give me a limit. They want to determine all the ordered pairs A, B. Now, certainly there's work down over here. When I go to the whiteboard, I'll explain through what work I would do to do the problem. All right, so let's go to the whiteboard. Oops. And I'll write the problem down. And the problem, pretty simple to write down, it's a limit problem. And you get the limit as x goes towards 0. And the top is just simply sine. That's being squared of x. And the bottom is e to the ax. Let's see, minus bx minus 1. They say it equals 1/2, all right? Now, if I were looking at this thing over here, the first thing I'd notice is that it looks like a L'Hopital, right? And what do I mean by that? The limit of the top goes towards 0, and the limit of the bottom also goes towards 0. Because when you plug in 0 on the top, you get the sine of 0, which is 0, and 0 squared is 0. On the bottom, you get e to the 0, which is 1, minus 1, that's 0, and then the b times 0 is just 0. So L'Hopital's rule is going to work on this one. At least you assume it's going to work. So let's put that down. So I'll put this over here, equal sign. I'm going to use the h indicating using L'Hopital's rule. And I get this over here, limit. And L'Hopital's rule, I take the derivative of the top, which is 2 sine x times the derivative of sine x, which is cosine x. The derivative of the bottom is, let's see, a, e to the ax minus b. And by the way, this limit also, if L'Hopital's working out, is going to be 1/2. All right. Now looking at that, I noticed something right off the bat is the top is an identity. Might make it easier for me to look at. That's a double angle formula, just simply the sine of 2x. Right, so that's not so bad. And what's the bottom going to be? Well, not much I can do about that. Get this over here. All right, what I notice about the top, I notice the top is going towards 0. And I certainly would like to use L'Hopital's rule again. So the assumption being made here is the bottom is also going towards 0. All right, so what I want to do is write that down. And I want the limit now, because then we're going to use L'Hopital's rule. I want the limit as x goes towards 0 of a e to the ax minus b. I want that to be equal to 0. And what do you get there? Let's take a look. You would get, what's going towards 0? What do I get? That would be equal to a minus b equals 0. That really doesn't tell me how much, does it? It's telling me like a equals b at this point, all right? However, I still want that bottom to go to 0, by the way. So I'm just going to say, let's just use L'Hopital's rule again, by the way. But I do know that a equals b at this point. So I'm going to use L'Hopital's rule again. Again, I want that bottom going towards 0. I'm not sure how to do that yet, because a does equal b, but it doesn't tell me much. This is going to be 2 cosine of 2x. I'm using L'Hopital's rule again. This will be a squared. Let's see, e to the ax. And again, it equals 1/2. Now, what do I know? I know the limit of the top now, and I'll just indicate this over here, that this is going towards, when x goes to 0, this goes to the number 2, which means this over here needs to go to the number 4. All right? So let me write that down now. So the limit as x goes to 0 of a squared e to the ax. Well, if I did that, I'd just get a squared. Because when x goes to 0, a times 0 is 0, and e to the 0 is just 1. And this is supposed to be equal to 4. So I know the a now is equal to plus or minus 2. All right, so now I can actually write my ordered pairs down. And the reason for that, I got this over here. And what can I write down the ordered pairs now, which is the question? If A is 2, the B would be 2. If the A is minus 2, the B would be minus 2. And we are done. Thank you.